Hey guys, welcome to part 3 of the grid tutorial. In the last one, we finished writing this create line function, which was the bulk of where the magic happens. So at this point, we go back to the construction script, and I realized at the end of the tutorial I had accidentally done something wrong. So we come back here to where we're calling create lines. I accidentally passed the line opacity for the thickness, which is obviously not right. We want to pass the line thickness. So drag that in and replace that, and I also did it down here. So make sure you replace the line opacity with the line thickness, and it's hooked up to thickness like so. You might have even caught that as I was doing it because it was pretty dumb, but that should be line thickness. So at this point, we can actually go ahead and create our grid so we can actually see it. So to do that, we're going to use our procedural mesh. So drag that component in, and we want to call a function off of it called create mesh section. And what this is going to do is basically what it sounds like. It's going to create a mesh based on the vertices and triangles that we give it. So the section index, we can just leave as 0 because it's basically for if you're adding more than one section to a mesh, like you have a mesh that's composed of multiple meshes, then you'd have multiple sections for it. But since we're drawing the whole grid as one mesh, we just want to set this to 0 and leave it as 0. And the vertices is going to be down here in our local variables. We want to pass in the line vertices and the line triangles. And again, these are just the variables that we filled out when we called create line, right? And yeah, that's all we need to set for these. At this point, we should be able to compile it and go to our viewpoint. And oh, yep, we can see our grid. It's a little bulky size. I think that's because I have my line thickness set really high. So I changed it to 100. But if you change it to like 10, actually, I think you should even have it at 10 if you're following the tutorial. Then you can see we have our grid. And we can kind of test things out a little bit at this point to make sure things are working. So, we can try setting the grid rows to 100, and you see it goes to 100. If you set it to 1, it goes to 1, and make sure the number of columns works as well. Set this to 1, and we got a nice little 1 by 1, set it to 100. Yep, that's probably 100. But I'm just going to set it back to 10 by 10, since that's a nice size to kind of work with. We can make sure the tile size works, so we change this to 100. That looks like that's working pretty good. Change it back to 200. The line thickness, well, we already saw that that was working because I had that set pretty high before. That's working. All right, so the line color and like the selection stuff, obviously we haven't done all that yet, so it's not going to do anything if we change it. But we have done some of the groundwork already for the line color when we created that material at the beginning. So we can actually hook that up really quick. So back here, after we create the mesh section, we want to go ahead and set the material of this mesh, which is our grid, to the material that we created way back at the beginning, right here, where we said create material instance, and we created one for our lines, and we gave it our line color and our line opacity. So this is our material that we want to use. So, it's called line material instance. So back down here, after we create the geometry, we can drag in our procedural mesh, and we'll say set material, and hook that up like so. And the element we want to be 0. And the material, again, is our local variable for the lines material instance. And hook that up like so. So if we go ahead and compile and run it now and go back to our viewport, ooh, look at that. You can see it's nice and green because that is what our line color is set to. If we go and we change this, you can see it updates all nice and pretty. We'll stick with the nice green color. That looks pretty cool. So yeah, so that's already hooked up and working. Pretty easy. Go back to the construction script again, and let's see, what are we going to do next? So let's add a little comment around this, because we're good programmers and we comment things. So highlight it, press C, and we will say that we are creating, so create the procedural mesh for the lines. That's basically what's going down right here. And after that, really the only thing we need to do in terms of creating geometry for things is we need to create the selection geometry. Because if you remember in the original video, whenever I hovered over a tile, it would show that tile with like a white, or whatever color you set to. white square inside of it to show you that you're hovering over it. So that little white square is actually geometry that I created, just like we created lines. And then I just kind of move it around to show whichever one you're selecting. So to do that, we already have this handy dandy little create line function that we're going to kind of repurpose and use it to create that square. So we're going to add yet again another then to our sequence. And down here, we are going to drag it and we're going to say create line. Except this time we're not really creating a line, we're creating a square, but we can use our create line function to create a square in this case. If you want to rename it to like create geometry or create square, then you can, but I think it's fine for this. So again, we want to create a little square that fits nicely inside of one of these squares. And by default, we're going to create it down here at the bottom left. So, and then we'll kind of move it around and change its visibility as needed in code. So back in the constructor script, we have everything right here. We just need to fill out these parameters correctly. So split those like we did before. And then start x, and yeah, so the start x is going to be 0, except we want to change the start y, because the start y is going to be, if you think about it, we're drawing a line and we can control the thickness of it. So we want the line, if you can see my mouse, we want the line to go right up the middle, like right up the middle, and then we want the thickness of it to fill out so it fills the whole square, right? So we want the line to start right here where my mouse is. So go back to the constructor script. So for that, we want it to be at the tile size divided by 2. So float divided by 2. So that's where it's going to start on the y. And it's also where it's going to end on the y, because we want it to end, to start here on the y, and up here it's also going to be on the same y value, because we want it to end up here. And the end x, we want to be the actual tile size itself, because again, we want it to start down here at 0 and end at the height of a tile on the x. So those are the values we want to pass, and then the thickness is just going to be the tile size, so that it fills the whole tile. And the vertices, again, we'll just go ahead and create local variables for these. So promote to local variable, and we'll just call this selection vertices, and we'll do the same thing for triangles. And this function will handle actually filling these out. We just need to create them and then pass them along, which is really nice. So the selection triangles. So yeah, so this is going to create it for us. And then the only thing we need to do is add it to our procedural mesh. Now, we could add it to this procedural mesh like we did up here, and we could add it as another section. But if we do that, we won't be able to move it around independently on its own. So in order to do that, we're just going to add another procedural mesh for our selection. So add another procedural mesh, and I'm going to go ahead and rename these just so it's a little more clear. So this is I'm just going to add lines in front of it, so we know this is the one for the lines, and rename this one to selection procedural mesh. So this is the procedural mesh that will create the selection for us. So go ahead and drag this in, and we want to do exactly what we did up here, where we say create mesh selection. So we'll say create mesh section, and hook that up like so. And the section index is 0. The vertices are just our selection vertices, and the triangle is our selection triangles. And yeah, so if we go ahead and we look at it now, we should have a nice little square here inside of our bottom left tile. And right now it's just gray because we're not actually applying our material to it, but we can easily fix that just like we did before. So I'm just going to copy this set material, bring it down here. Except for this case, we want to use this selection procedural mesh instead of the lines procedural mesh. And we want to use the selection material instance instead of the lines material instance. And so we can file save that, go back to our viewport. And so now you can see it's this nice white color, and we can change it by changing the selection color. So you can see whatever I changes to will be the selection color, so they will make it red. And we should also be able to set the opacity. So if we set the opacity of the grid, or the lines in this case, we'll set it to like 0.2. You can see it fades out, but I think 1 probably works best for the grid. And then the selection opacity, I like, 0.25 or something kind of dim, so you can kind of see through it, right? So yeah, so it looks like all of our variables are working, which is pretty swell. Yeah, so we'll go back to the construction script, and things are working out pretty nicely. So we will comment this and say create selection geometry and procedural mesh. I think I spelled that all wrong, but that's okay. Yeah, so that's what's happening down there. So again, just to recap what's going on, we originally create our horizontal lines geometry, we create our vertical lines geometry, we create the procedural mesh for the lines, and then down here we're kind of doing it all in one because it's much easier. We're creating the selection geometry for that little square, and then we're creating the procedural mesh, or we're adding it to the procedural mesh, and then we're setting the material on it. So yeah, that is it for our grid. Now, obviously we haven't filled out these public functions yet. Yeah, so we're going to write these functions, and these are just kind of like functions that I thought it would be super useful to have for a grid. But again, based on your game, you can write whatever type of functions you might need for your grid. But these are like some pretty basic ones that I'm pretty sure most people will need. So if we go ahead and let's actually bring this guy into the world. So I'm going to change the show, where is it? Navigation, turn that off so we don't have that giant green thing. And I'm going to bring this grid into the world. We just drag it in. So one thing we should probably do is turn off, bring it a little bit above the ground so it doesn't clip. All right. So one thing we should probably do is turn off this tile because we're not actually hovering over it. So by default, we should set its visibility to invisible. So where do we do that? So right after here, when we create the lines for it, before we actually create this selected procedural mesh, we want to set its visibility to invisible by default. So just copy this selected procedural mesh and say set visibility, and we want to set it to hidden, so just leave this visibility unchecked. And now if we go back to the viewport, it's not there, and if we go back to the game, it's not there, because we want to be able to turn that on like, at runtime, depending on where the mouse is. We don't just want it always to be there, right? Okay, so again, so if I play the game, you can see, like, obviously I want to be able to click in these squares and have them highlight, and I don't want to be able to walk out of it. Like, all this good stuff is basically what I'm going to be showing you how to do next. So yeah, so let's think about it. So there's two steps we really need to do here. We want one for when you hover over something. We want to be able to show that little selection inside of the square. And the other thing we want to do is make it so when you click, like even if you click the top left corner, the top left corner of this grid, we still would want your character to go to the middle of it as opposed to going to the top left corner, because it's, like a grid-based system. So I think the first thing we're going to do is figure out the hovering state. So if we go to the codes, I think it's in top-down blueprint, blueprints, and I think it's in this guy. I think it's in the character that does this. Maybe I'm wrong. No, okay. Get position of mouse in world. So so yeah, this is the juicy part that we want. So let me open up my code so I can actually reference it, because we're going to be changing a couple things here, just so we can add in the stuff that we want. Okay, so yeah, so I'm going to take all of this, everything inside of this event tick in the false section. We're going to tick this, we're going to right click, and we are going to collapse to a function. And this function is going to be called, if I can rename it, click it over here, F2, and it'll be called update cursor position. And this is also going to handle showing that selection on the grid for where your cursor is. So we kind of drag this up here. And if we click on this, this should probably be a private. And I'm going to move it to a private function or a private category just so it's nice and neat. So if we double click on this, you can see Unreal has kind of collapsed this for us. Not in a great way, if I do say so. Let's kind of clean this up a little bit just so we can read it. Yeah, okay. Something like that. All right, so we want to change this because right now this is basically, all this is doing is it's getting the position of the cursor and figuring out where it is colliding with the ground, and it's drawing this neat little green thing, right? But we also want to use this to draw our selection. So the first thing we're going to need to do is we're going to need to get access to our grid. So currently we don't have any way to do that. The way that I would recommend to do it is to make it a variable that gets saved inside of your game mode, and then you can access the game mode from anywhere, so therefore you can access the grid from anywhere, because it's kind of like a global thing. You're going to want to be accessed all over the place. So let's go ahead and do that real quick. So go back to here, and then in the top-down game mode, open that up. And inside of here, we just want to click Open Full Blueprint Editor, and we want into the Begin Play, so Event Begin Play. We want to get all the actors of class, and the class that we're looking for is our BP grid. So this is going to find us the grid, and we're going to get a copy of 0, which is the one and only grid, and right-click and promote this to a variable, and hook that up, and we will rename this to grid. And we want this grid to be private, and again, I'm going to put it in a category called private. And then we want a function to be able to access it, so we will make a function called getGrid, and we want this to be public, which it already is. We want it to be pure, we want it to be constant, and we'll drag in the grid and hook that up like so. All right, so simple little function here for getting the grid. And again, just the beginning, as soon as the game plays, it looks for the grid and it saves a copy of it. One thing to note real quick, if you plan to like sometimes have the grid in your level or sometimes not have the grid in your level, you're going to want to do like a check here to make sure it actually finds the grid, because if there's no grid in your level, then bad things are going to happen. But if you know the grid is always going to be in your level, then this is totally fine. Because if somebody creates a level with no grid, you're going to want it to like error out and like not work because there's no grid, right? So yeah. Anyways, so now that we have the ability to get access from the grid from anywhere, we can go back to our top-down character, and I'm going to drag this over to the left a little bit. And so the first thing we want to do is get access to that grid. So we will say get game state, or get game mode, sorry, and we need to cast it to our game mode. So cast to, I believe it's called this top-down game mode is the current one. So cast it to the top-down game mode. And then from here, we can say get grid. And now we have access to a grid. And I'm just going to store that as a local variable. So promote to local variable, just so we can easily access it. And we will just rename this to grid. And make sure I'm recording. Okay. So that's our grid. And now that we have access to our grid, we kind of want to do some stuff. So the first thing we're going to want to do is, you can see right here, it's saying get hit result under cursor by channel. And it's not currently checking if it's hitting anything. But in our case, we really do care if it's hitting something, because if the mouse is not over anything, or if you're looking at the sky, like we want to know, because we don't want to actually show any tile as selected if you're not hovering over a selected tile. So drag off of this boolean for the return value and say branch, and hook this up like so. And we'll say if it is true, we're going to want access to this location a little down the road. So we're going to also right-click on this and promote it to a local variable and save it if it's true. And we'll call this the hit location. And we can hook that up like that instead, just to make it a little neater. And hook that up so it still happens. Put it up there, I guess. So yeah, so if it's true, we want to do what it was already doing, because we don't want to change that behavior. And then we also want to do some stuff with our grid. So we want to set the selection, right? So we'll drag in the grid, and the first thing we want to do is we want to convert this location that the cursor is hovering over to a tile. So we have a handy function for that, which I believe we haven't written yet, but we can do that right now. So we'll say location to tile. And again, this is going to take that location, so we'll drag in our hit location. And it's going to convert it to a row and a column, and it's going to tell us if it's valid or not. So let's go ahead and write this real quick. So double click on this. And inside of here, we need to do some math to figure out, we want to basically convert this location into a row and a column. So we're going to do, let's just do it this way. So right click and say get location. And we're going to do that. Yeah, okay, sorry. I'm trying to figure out the best way to do it. So yeah, get location, and then right click, and we want to split this because we only care about the X, because we're going to be calculating the row first. So get the location that is passed in, and we want to get the location of the grid, so get actor location, because that's us, right? And we want to split this as well because we only care about the X. And we want to subtract those so we can get the difference. Minus, I'm going to type minus. And then we want to divide that by the grid width itself. So float divide. And we'll say get grid width. And then we want to multiply that by the number of rows that there are. So get the number of rows. And float multiply. And then this is going to return as a float, but we don't want a float because we want like whole numbers like 1, 2, 3, 4. We don't want like 2.5, for example. So we're going to say floor, which is going to basically get rid of any decimal point remainders on that. And so this is going to be our row. So we'll just kind of put a little comma here. So that's the row that we're in. And then we want to do kind of the exact same logic, just with a couple different values for the columns. So I'm just going to copy this, put it down here below. So this is for the column that we're on. For the column, we want to use the y value, and we want to use the y value, so make sure you change that. And we want the grid height, I believe. I actually realized in my code I have this wrong because I still have it as grid width, but I believe we want the grid height here. Yes, I'm pretty sure that's right. I'm just thinking about it for a second. Yeah, because it's the columns. And yeah, okay. So we want grid height here. I just realized that that's wrong in my other project. Well, let me just fix that real quick on my other monitor. Okay. And then up here, we want the number of columns. And we want to floor that. And this is the column that we're on. So now we have the row and the column. We could just return these values up here. But as you can see, this also wants to return if it's valid or not. So before we do that, we want to check if it's valid. And we have a little macro for that we created. So we'll hook this up first, and then we'll actually fill it out. So hook it up, and this will tell us if it's valid or not. Our row goes up here. Our column goes up here. I'm going to scooch this over. And then regardless of if it's valid or not, we still want to return the row and the column. So we'll return the row. And try to make this a little neater. Oh, I can't. This is ugly. Has to be perfect. Okay, close enough. Just so the lines don't cross too badly. So yeah, either way, we're returning the row and the column. But we need to fill out this tile valid macro real quick, which is pretty simple if you think about it. Because like the row and the column, obviously these need to be greater than 0. Like they can't pass in a -5 for either of these, and they need to be less than the actual number of rows. So if there's only 10 rows and you pass in column, or if you pass in a row value of 25, then that's obviously way too large. It's not valid, so we want to return false. So we want to check that this is int greater than or equal to 0, and we also want to check that it is int less than the number of rows. And then we want to do the same thing for the column. So we want to say, is the column int greater than or equal to 0? And is it int less than the number of columns? And make sure you have like the greater than or equal and the less than like correct. Make sure you're using the or equals correctly. So it's greater than or equal, less than, greater than or equal, and less than. and then we just want to AND all this together basically because we want all of these to be true. So and we'll just AND these together as well. And so if those are all true, then it returns valid, right? So pretty simple. So we can go back to location to tile. And so this function is now done. And this macro is filled out, so it should work just fine and dandy. So we can go back to our top-down character. And inside of here, we're converting the hit location into a tile location. And the next thing we want to do is we want to say grid set selected tile to whatever tile was returned from this. So we'll drag this in and set the row and we'll set the column. And in this particular case, you can see I'm not actually checking this valid variable. And the reason I'm doing that is because when we write this function, we're actually going to write it so that if the row or the column is invalid, it's going to hide the selected tile. It's not going to show a selected tile, which is exactly what we want. So if it's invalid, like it's totally fine when we call this function because it's just going to hide it anyways. So we come in here, we just need to write this function real quick. So, all right, so yeah. So this function is not too crazy. The first thing it needs to call is tile to grid location, which is going to be a little bit more crazy of a function, but we haven't written that yet. So we'll have to do that in a second, but just go ahead and hook this up. And for a center, we don't want to select this because we actually don't want the center of the tile. We want the bottom left corner of the tile because that's where we want to start drawing the selection from. And we'll drag in a branch here for if this is valid. So what this function is going to do, and again, we have to write it still, but it's going to convert the tile location, so it's going to convert the row and the column into a grid location. And what a grid location is it's still a position, or it's still a location in world space, but it's at the center of the tile if you select this, and if you don't select this, it's at the bottom left of the tile. So if the grid location is valid, then we want to say that our selection procedural mesh, which again is just that square, we want to set its visibility to visible like so. And if it's not valid, then we want to set its visibility to invisible because it means that, you know, perhaps the mouse is looking at the sky or it's just somewhere that's not in the grid. So we don't want to show any tile as selected. So we want to set it to invisible. And okay, so yeah, so if it is valid, then we want to take this value and we basically want to set the location of the selected procedural mesh to that location. So actually, so let's copy this procedural mesh, paste it over here, and we will say set world location and drag that up like so. And go ahead and split this new location. And the Z value we don't actually want to change. So let's just say get actor location and split this as well and hook up that Z. But the X and the Y we do want to change, and they're going to be the values that come out of this grid location. So drag this over, and we want to say, break vector 2D into an X and a Y, and we'll hook those up like so. And we'll make this a little neater. All right, so this function is good to go, but of course we need to write this function, and this is, I promise this is the last like major function we need to write, because I know we're writing like all sorts of functions, but this is like pretty much the last one. So yeah, like I said, inside of here, this function is going to take a tile, so like a row and a column, and it's going to convert it to a grid location. So the first thing we want to do is we want to check if it's valid. So drag in our little is valid and hook that up. And we're just going to return that. But either way, we're going to do the math to figure out the grid location. And we're going to want to split this because we're going to return we're going to return them as separate, or like we're going to calculate them as separate values. So go ahead and split that. Okay, so to do this, we're going to say get row, which again is just this parameter right here. And we're going to multiply this by the tile size, like so. And we want to add this to the current actor's location, which is the grid's location. So get actor location. And we want to add it to the X. So split it and hook it up like so. And then we want to do something very similar. Well, actually, we'll just finish this first. So yeah, so we're getting the current row that is being provided times the size of the tile plus the actor's location. And then depending on if center is true or not, we are going to want to add to this value, because this is going to just give us the bottom left corner of the tile. But if center is true, then we want to, go to the middle of the tile. So we're going to say, oops, not that, get center, and we're going to do a select off of this. And if it's true, well, let's hook this up first. So we're going to say float plus something. So something is going to come from our select. So if it's true, we're going to do the half the size of a tile, basically. So get tile float divided by 2, because we want to go to the center. So we're going to do half the tile size, right? So that's true. And if it's false, we just want 0, because we don't want to actually add anything. So yeah, that's going to be our, that's going to be our grid location X. And our grid location Y, we're going to do very similar, except we're going to be using the Y value here, and we're going to be using columns. So we're saying get column. And again, we want to do float times the tile size. And then we want to say float add, and add it like so. Drag this down a little bit so we got some room. All right. And then again, we want to say float plus, and we're going to be adding this value. And then this is our grid location Y. So there you go. So that is that function all written and good to go. So I think we are, let's see, is everything? Yeah, so that's good. So if we go back to our top-down character, we're getting the location of the tile that was clicked, and then we are setting the selected tile to that tile. And then the only other thing we need to do is back here on the left where we have this branch for if we hit something. If we don't hit something, then we basically we don't want to show the selected tile, right? We don't want it to show. So we're going to, again, say grid, set selected tile, and a quick little way to just hide it is just pass in negative values, because of course these are invalid values. And if you remember the set selected tile, if it's not valid, then it's just going to set the visibility to invisible. It's going to hide it. So it's basically just hiding the selected tile. So if we go ahead and we run this, hopefully this should work. So yeah, so if you hover over a tile, you can see it's setting the selection to that color. If we go off the grid, it's completely hiding it. Or yeah, if for some other reason we were not looking at the tile, or we were not collining with the tile, then it would hide it. But as you can see, it's still not moving us really to the center of the tile, because we haven't written that logic yet. It's just kind of putting us like exactly wherever we click. You can see if we click at the bottom, it drags us, or it brings us to the bottom. If we click at the top, it brings us to the top. So that's the very last thing we're going to do, and I'm going to do that in the very last video. So I'm going to go ahead and end this one, and then we will pick it up right here in the next one.